My name is Dr. Fanikumar Shinde, Assistant Professor, Department of CSE, Space Institute of Technology and Sciences. Yeah, in this session, we will see the second part, the continuation of the previous session. Like we can see here, these are the topics we will cover in this session. Like you can see, what is an API? Here we can discuss about API and what are the different types of web services we are having, SOAP API and REST API, and what are the different types of integration patterns we are having for developing an API. Let's see one by one. Like what is an API? You can see here, it's an application program interface. API abbreviation is application program interface. Let's you can see here it is an interface between any two applications. Like what you are performing here with Mulesoft. In Mulesoft, we are performing an integration between any two applications. We are transmitting the data from one API to another API. Otherwise, one application to another application. That's we are saying it as integration. For that integration, here we can create one API. Here API task is to perform integration. Let's you can see here what it has. An API is an interface between multiple applications. It means that it allows two applications to communicate. Actually, we cannot say it is between only two applications. It can communicate between any number of applications to any number of applications. And an API follows the principles of question and answer exactly as humans do. That means like it's an interface, that means it will be in mediator in between the two applications. Like one application will send a request and then another application will send a response back for that. That's we are saying as integration, and that will be performed with API. Let's you can take an example in this picture. Let you can see here. Let's you can see here. Here we are having a client and we are having a server. Now in between the client and server, like here we are sending a request and response. Like the client requests some request to the server and the server will send a response to the client. But instead of direct communication in between this client and server, here we are using an API. Now what is the API task? API is between the client and server, otherwise one application to another application. The client will gets the request from the source and then it will send that one to the server, and the server will process on that request, and after completion of this process it will send a response back to API, and this API will send a response back to client. That's why we are saying it as a request and response. Now go to the next one. Yeah, let's see the types of web services. Like what is the web services first? Before going to see about the type of web services, let's see what is the web services. Like here the APIs are between the two applications we are saying, and these two applications will be send an HTTP request and HTTP response, like HTTP request and response. Now these HTTP request and response will be processed in a web servers. In a web servers, here these requests will be processed. That's why here whatever that APIs we are building, here those will be performed in web services. We are having two types of web services. One is the SOAP and second one is the REST. And here we can see individual, what is the SOAP and what is the REST APIs. Now SOAP, it can be called as simple object access protocol. Here it is also an API. Like we can create either SOAP APIs or REST APIs. Now before going to that, let's you can see at previous days we have both the SOAP and REST APIs, but nowadays mostly we are using the REST APIs. Now why you are using only the REST APIs instead of SOAP APIs, that we will see later, because of we have some limitations with the SOAP API, that we will discuss within that. Then after that, why you are not using the SOAP APIs in the current now. Let's see here the SOAP is the abbreviation is simple object access protocol. That means it's a protocol first and is a web service that uses the SOAP protocols. What is the protocol we are using? SOAP protocol. And what is the API? It is for integration, that means to exchange the data. That's why it can exchange the message between servers and clients, like which we have seen in the previous slide, client and server request and response. Now in this case, like the messages must be written in XML. Now you can see here, it is the major part. Like if you are using SOAP APIs, like it can perform, otherwise it can accept the request in the form of XML, and it can accept the response is also in the form of XML. That means it won't support any other data formats. It supports only XML in accordance with the strict standards. Strict standards. That means XML. All of you know that XML means it's an extensible markup language. It requires some tags, and those tags also contain some namespaces. For these, here we are having some headers, and all these components will be there in XML. Here, those will present in a standards, and if you are not use those standards, then it will give an error. Then we can see the REST API, then we can understand what is the difference between the both and why you are not using the SOAP API. Instead of that, why you are using the REST APIs. Then comes to REST API. Now the abbreviation for REST API is representational state transfer. Representational state transfer. Now what is it? Here API typically receives requests for data via the HTTP transfer protocol, which you are discussed earlier. Like here both the request and response is the form of HTTP, because of these are web services which will be perform operations on web applications. And once a request is received, REST APIs can return the message in either HTML format, XML format, plain text, and JSON. And not only JSON, here we also have CSV. We also have CSV. Like we can compare the both the SOAP and REST API. Let's you can see here. Like the REST API can support HTML, XML, plain text, CSV, JSON. Here we have different types of formats the REST API can support. But in the previous, you can see here, in the previous, like a SOAP API, the SOAP API can support only XML. Only XML. That is the drawback which you are having in XML. And not only that, if you are using the XML, also we are having some drawbacks. That's also we'll discuss. And first you can see what is the REST API which can perform. Here in the REST API, it can be accept any type of files, formats, and because it can be read by any programming language, is mission and human readable, and is lightweight, and it is lightweight. That means compared to XML, the JSON, otherwise whatever the formats which are displayed here, these will allocate very less amount of memory. If it has a less amount of memory, because of here we are transmitting the data from one application to another application in a cloud server, otherwise in an on-premises services. That means through internet we are transmitting the data. If the data size is high, then it will take more time to complete that. And if you are using the REST API, then it is very lightweight. That means very less amount of memory that file will be occupied. And mostly here we can see the JSON. It's a JavaScript object notation is preferred as a message format. That means by using REST APIs, mostly it can support all these type of file formats. It can support all these file formats. But by compared to all, most of the applications, they use JSON. They use JSON for file transfer. And we are saying that the JSON is a very lightweight. JSON is very lightweight file format. That's why it contains a very less amount of memory. If it is having very less amount of memory, means we can easily transmit the data from one application to another application through cloud. That is the reason here we are saying that instead of JSON, we are mostly preferring the REST APIs. That means the organizations who are the clients which are preferring to develop the REST APIs. That's why in the Mulesoft also we are mostly using the REST APIs instead of SOAP APIs. Let's see the same thing in a pictorial manner. Like if it is a SOAP, like here it is an app, it is a server. Now, like a client and server. You can see here. SOAP is like using an envelope. That means if you are using a SOAP, then mostly it is in the form of envelope. That means it covers all the information. That means some other related, instead of the data, like whatever the data you want to transfer, instead of that, it covers some other data which are the nothing but a standards or some other parts of the data will be present in a SOAP API. That's why here it will be like this. And you can see here it is like a REST. It is like a REST. It is like a postcard. That means it contains only the data which you want to transfer. That's why by compared to the SOAP and REST, here the REST is very lightweight. Very lightweight. That's why but compared to the SOAP API, mostly we are preferring the REST APIs for transmitting the data. And comes to the major part. Here it is the major part in the Mule API development. Here that is integration patterns. Like we are saying that integration for transmitting the data. Now, what are the different types of patterns we are having for transmitting the data? Like we are having multiple, like migration pattern, broadcast, bidirectional sync, correlation, aggregation, and reliability. And we can see one by one how these patterns will be there and which scenarios, which one we can use it. Let's you can see the first one, migration pattern. Like we are having one vendor and then second vendor, like a one application and another application. Here it is migration pattern. Like let's take a small example. Here it is like SQL server, like MySQL server. Like initially the client is used the SQL server to store their records. Then after that the client want to migrate their MySQL server to Oracle server. Then in the migration pattern what will be happen? Whatever the records are present in this MySQL server, it may be a lakhs of records or millions of records, those will be migrate into Oracle server. Yeah, that is the migration pattern. That means how many records are there in one application? All the records has to be moved to some other application. That is the migration pattern. Then comes to the next one, broadcast pattern. Let's see the broadcast pattern. That means we are having one source, and you may have multiple receivers. In this example we are having 1, 2, 3 receivers. These many receivers we are having. These can be called as broadcast. That means from one source here we are fetching the data and then we are storing the data. That means we are sharing the data to multiple receivers. It can be called as broadcast. And then you can see bidirectional sync pattern. For this you can take a small example. Like in your mobile you are having a Google Contacts. Let's you can take here it is a mobile. It is our mobile. And it is Google Contacts. Now, what's going on here? Once you are updated one contact in your mobile, then immediately that will be updated in Google Contact. That means here both the devices, that means both the applications having the same records, that can be called as sync. But here our is bidirectional sync. That means in the Google also, in the Google Contact also, if you are update a new record, then the same thing will be updated in mobile also. That can be called as bidirectional sync. Now for this also we can develop applications, that means APIs, by using a Mulesoft. And then like we can see here the correlation pattern. Here it is somewhat related to bidirectional sync, but it's not exactly. Why? Because let's you can see here it is a bank branch 1, it is branch 2, and it is branch 3. Like here the branch has some customer details who has accounts of this branch, and this branch having some account details which are having some other customers which are belongs to that bank. Now what is happening here? Let's you can see, like this customer A initially is having account in X branch. Then after that there may be a chance the customer will be change their bank to some other branch like Y. Then here this Y branch of the same bank, there is no need to create a new record for the same customer, because of this customer is already belongs to the same bank but not with the same branch. Now what this branch has to do, this branch will send a request to the branch X, like I want this client information, customer information. Then this branch will share the data to the branch Y. That means here there is the data will be shared from one branch to another branch. Actually there is no need to maintain the both the branches with the same data, but both the branches with the having the same bank but not having the access to the same customer which are belongs to some other branches. In this case here one customer is changed to some other branch, that's why here the branch can send a request to the branch X and the branch X will verify that, then send that response back, that means that customer information back to branch Y. Now the branch Y will contains this customer information without adding that customer information again in that bank. That can be called as correlation pattern. And let's see aggregation pattern. It is like, it is exactly opposite to broadcast. In the broadcast what we are doing, from one source to multiple receivers. Like the same thing here we are having multiple sources, that means we are having data from multiple sources, we are getting the data from multiple sources and we are migrating that, otherwise we are storing that the data into a single receiver, like we are having multiple sources with one receiver. For this also we can take an example, like we can take some shipment, like you can take any courier services, let's take one of the courier service. Here initially they are having account details in CRM, like maybe a Salesforce, and some of the courier partner they are using like CSV file, and some of the courier partner they are using some Oracle database. Okay, like we are having three applications having the data in different sources, and finally here that courier database is present in we can say it as Azure database, Azure MS SQL database. And finally the courier services they are maintaining their master data in Azure MS SQL database, but the sources like their partners they are using their own databases for storing the client information. And finally here the partner 1 will send the data from Salesforce to database, and partner 2 will send the data in the form of CSV, and partner 3 they will send the data from Oracle database. And finally these all the data will be stored in a master database, that is Azure MS SQL. Now these can be called as aggregation pattern. Then you can see here reliability pattern. It's very important thing, because of this only here we are getting a safety of the data while transmitting the data from source to target. Let's you can see the issue with non-transactional transport like HTTP with transactional transports like DB. And if error occurs in second DB insert, then there is no provision of doing a proper rollback and add up in a partial commit. Let's see here, like it's an HTTP request. Let's take a small example. It's like a payment. It's like a online payment. It's like an online payment. Like it is the sender server, sender bank, and it is the receiver's bank. Then like a user, they used an online banking or any platform to transfer the amount from one person to another person. Then what will be happen? In this case, like the client is initiated the transaction. Now initially from the sender account the amount is debited, but at the time of receiving the data into the receiver's bank, here the transaction was failed. The transaction was failed. Then what will be happen? The sender account will be debited, but the receiver account won't be credited. Now in this case, like we lost the data, that's why the receiver won't receive the payment. Now in this case, we can use the reliability. Reliability means here without losing the data we can transfer. Without losing the data we can transfer. You can see how we can do that. You can see that how we can do that. The same thing. Like in the previous screen, what we are having from HTTP to database and database. But in between this, first we have to use one message queue. One message queue. Like we are implemented one queue in between the transaction to the initial transaction. Then what will be happen? First of all, whatever the transaction was done, initiated, that information will store in message queue. What's that information it contains? The initial ID, unique ID of this transaction, unique ID of the transaction. Then after that, sender's information, sender's info, and as well as receiver's info. Both the information is available in this message queue. Then after that, the message queue will transfer. That means DQ means it will, we are getting the data from message queue, and then that will goes to the fast transaction. In the fast transaction, what happened? Here the amount is debited. Amount is debited. Then after that, in the previous case, what was happened? Here in the receivers, while crediting at receiver side, it was failed. It was failed. Then what happened? Whatever the data is there, that data is already available in message queue. That's why whatever the transaction is failed, but the data is available in MQ. That's why here in this transaction, here banks will goes to this message queue and they can check what are the transactions were failed. What are the transactions were failed? Is there any particular transaction was failed here? Then it will check their transaction ID, like some ID, the transaction ID, unique one for this transaction. It will goes there and it will get that one, like whatever that information, like the sender's information and receiver's information, and it can be parsed the same back to again until the transaction is success. Okay, now here it is the reliability pattern. That means without losing the data, how we can transfer the data. Like to make this reliable, we can introduce a connector here, that is nothing but this message queue, to divide the transactional and non-transactional activities. Okay, and here these are the non-transactional activities, and these two comes under transactional activities. These two will be transactional activities. Now what will be happen? In these two transactions, any one of the transaction is failed. Any one of the transaction is failed. What will be happen? It will be rolled back whatever that operation is performed in the transaction 1. Like here the amount is debited, then after that in the crediting phase, here the transaction is failed. Then what will be happen? It comes to the previous transaction, and in the previous transaction what was the update were done, that will be rolled back. That means nothing was happened, and it comes to the active MQ, and it contains the whole information of this transaction, and it can perform the same transaction again. Okay, now it can be called as reliability pattern, and it is the these are the topics here which are covered in this session. And if you have any queries regarding this, you please contact with the given mail ID and the mobile number. Thank you.